Welcome to Aquarech LBDA, boss. I'm Overton from Watch. This is our greenhouse where we carry out Recirculating Aquaculture System, where we breed the tilapia eggs and also we ensure that we artificially incubate them. So when we come close to our system that we have, this is an incubation system that is basically responsible for the artificial incubation of tilapia eggs. The first step that happens here is that we bring the eggs from our brooders outside the ponds, where we have the males and female tilapia put in a hopper where they breed. So the ratio that is in the hopper there is conventional ratio that is known, that is 1 to 3. At every 1 male tilapia, we have 3 female tilapia. We collect the eggs from the mouth of the female tilapia, and once we get the eggs, we clean them using potassium permanganate and also some concentration of salt, which helps in regulating or rather preventing disease-causing organisms. Once the eggs are cleaned, we bring them here and put them in these jars here. So the jars are responsible for the hatching process. As you can see, we must ensure that they are in constant rotation. This rotation is very important, number one, because it ensures that each and every egg is well aerated and they don't suffer from suffocation. Number two, it also prevents the eggs from clumping together, and the result of clumping together is they are dead. And number three, it also makes the eggs to move away from maybe some pathogens that could be present in the water. So that's the reason why we must ensure that they are always in constant movement or in constant circulation. So within 2 to 3 days, the eggs that are here start hatching. So after they have hatched, they move on their own, the swim-ups move on their own and pass through this pipe here, where they land into the trays. So in the trays here, we also have the newly formed fry. So the next stage from the egg is the fry. So we have the fry inside here, which are also still kept in a constant movement to ensure that they are also getting enough oxygen. So we have the fry here, which will take about 2 to 3 days also, so that the yolk sac is totally absorbed. So once the yolk sac is absorbed, the fry is ready to be sampled, to be counted, and taken now to the rearing tanks. These are our rearing tanks. Now, for this process to be successful, we have got a number of factors that we must maintain. We must ensure that we optimize them. Number one, we must ensure that the temperature of this particular structure is at optimum. That means between 27 degrees Celsius to around 30 degrees Celsius. Number two, we must also ensure that the pH is kept at the range of between 6.8 to 8.5, and also the ammonia levels must be as very low as possible. If possible at all, there should be no ammonia in this facility, on this particular structure here. So in order to achieve that, we have got different kits that we can use to monitor such parameters. Number one, so we can record the temperature using this thermometer here. So it's falling within the range. We have 28 degrees centigrade, and that's an optimum range for the hatching process. So we also have got the test kit for pH, the strips that are also available. We can identify, we can use them to establish the correct range of pH here. Now, besides all those, we also have the filtration chamber, which is now categorized into two. We have the mechanical part. The mechanical part is the one that is responsible for doing away or trapping the solid particles that could be present in the water. So we have these rush filters. Once the water passes from the mechanical filtration part, it goes to the biological filtration part, where we have these biofilter balls. So in these biofilter balls, we have the biofilm inside here that are responsible for creating harbor, a place of rest for the microbacteria that are responsible for converting the excess ammonia that could have accumulated in the water into nitrites and also into nitrates, which are now less toxic. So when this water recirculates, there's ammonia accumulation because, number one, we have got some eggs that are dying here. So when those eggs die, the ammonia builds up, and also the yolk sac here, when they are breaking, the ammonia accumulates. So besides the mechanical filtration part and also the biofiltration part, we also have the UV lamp here. So UV lamp simply is responsible for sterilization. So it ensures that this water here is pathogen free. So it kills those microbacteria that could otherwise be present in the water here. So for all this system to be complete and efficient, all the parameters must be kept constant. All the components must be put into good use to ensure that the productivity of this particular structure is not compromised. So once these eggs hatch here, and we say that they take about 6 to 7 days for complete hatching to take place. So 2 to 3 days from hatching, from eggs to hatching, then post-hatching, now 2 to 3 days for the yolk sac to be absorbed so that the fry can be free. Now, post-hatching activity, we take them from these trays here, we sample them, we identify the number, and we stock them in these tanks here. Now, in the tanks, we can stock up to between 40,000 to 50,000 pieces of fry, and whatever happens here is very simple. So we take them here for 21 days for nursing, 21 days, and this is where the sex reversal procedure takes place. So within 21 days, we are going to feed them through the sex reversal hormone, where we end up with the monosex. In monosex, I mean the all male population, and that's the one that we take to the market for the farmers. We simply use an hormone to administer in that feed. So we use methyltestosterone hormone, alpha 17, together with ethanol, because the hormone is ethanol soluble and water insoluble. That's why in most cases we use the ethanol instead of water. These tanks also, they have got inlets, they have got outlets, which brings in clean water and takes away the dirty water respectively. So with us here, we have the filtration chamber for the water that goes into these tanks here. So the blue tank on my right hand side here, water that comes from outside, from the source, it first lands into this blue tank here, where mechanical filtration takes place. So that, as there, we also have the drum filter, where solid particles are expelled or solid particles are removed in that filter there. So from the mechanical filtration part, the water flows through to the white tank, which is on the other side. So in the white tank there, that's where the biological filtration takes place. We have got biological components like the ones we saw in the incubation system. So we have got biological filtration taking place here, where ammonia is done away with. Ammonia is gotten rid of. Once the ammonia is gotten rid of, the water simply is pumped up into that overhead tank. So from the overhead tank, the water is supplied in all the tanks. Now, when the water is in these tanks here, we ensure that flow through is done on regular basis, almost on daily basis. So flow through means fresh water entering and also the dirty water coming out. Now when the dirty water comes out, it also finds its way up to the blue tank. And from the blue tank, the mechanical filtration takes place, the biological, and the water up again. So it's a continuous process that continues. So in the tanks also, we have got the aerators. You can see the blowers there. They are responsible for ensuring that the oxygen levels are optimal. We must ensure that all the water quality parameters are kept at optimum, and that one ensures efficiency and also productivity. So basically that's what happens here, and you can see it's a greenhouse, so we ensure that production is all season. It's carried out almost all season because we are not affected by the climate, we are not affected by the weather. Whatever happens inside here is simply the recirculation of water, because we try as much as possible to ensure that little water or no water at all goes into waste. So we take the water from outside, we pass it through the filtration process, both mechanical and also the biological one, and from there the water is supplied to all these tanks. So the same water is taken back from the tanks now to the main chamber for the filtration. So it's a process that is continuous. Yeah, so we ensure that water is conserved maximally.